Hello, I'm Jack. Welcome to Practical Programming channel. In this video series, you will learn everything you need to get started with WebGPU Graphics Programming. In the last video, I explained how to create a 3D sphere wireframe. In this video, I will show you how to create a cylinder wireframe. The main purpose of this example is to illustrate how to construct vertex position for 3D objects in different coordinate systems. To do this, we need to use the cylindrical coordinate system as shown here. This gives the relation of the x and y coordinates with the r and theta, these variables in cylindrical coordinate system. To create a cylinder wireframe, here we will consider a general hollow cylinder. It is empty from the inside and has some difference between the inner and outer radius as shown in this figure. Here we divided this cylinder into many slices to form a surface grid. The unit cell is formed by the S and I plus 1 slice line. You can see each unit cell contains 8 vertices and 4 surfaces: top surface, bottom surface, inner surface, and outer surface. The side surface is invisible, it doesn't count. And 12 lines, 8 solid line segments and 4 dashed line segments. For each unit cell, we only need to draw these 8 solid line segments as shown here, because the 4 dashed line segments will be drawn by the next unit cell. This can avoid drawing the same line segment multiple times. In this way, if we run over all the grids, we can create a wireframe for the entire surface of the cylinder. Okay, let's go back to the programming part. Again, we will use the Git tool to clone the source code used in the last video. Here is the download link at the GitHub repository. From this link, you can download all the source code used in the last video. Now, open a command prompt window and run the following command: git clone, and copy this link. This will generate a WebGPU 13 folder on your local machine. This folder contains the source code used in the last video. Now we want to change the name of WebGPU 13 folder to GPU 14. Rename 14 and cd into it 14. At this point, we are going to start Visual Studio Code with the command code period. This is a Visual Studio Code interface. Okay, we can close this welcome page. Now here contains all the source code used in the last video. Now we can open a new terminal window and run the npm install command to restore the npm packages. Okay, finished. Now all the installed packages are stored in the Node modules folder. Recently, the WebGPU working group just released a new version of the API. That is version 0.1.4. The biggest changes in this new version is that it merges swap chain into canvas context. This means there is no swap chain anymore in WebGPU. I have created a short video that shows the detailed step on how to update the example code to reflect this new change. You can search the code update to video from my channel to learn more about the code update. Starting from this video, I will incorporate this new feature into our example code. Now open the package.json file. From here you can see WebGPU tabs. The version is 0.1.2, so we are currently using this version. Now we can update it to the latest version with the following command: npm update WebGPU tabs. Now you can see the WebGPU tabs, the version becomes 0.1.4, which is the latest version. Now we need to make some changes in the helper.ts file. From this src folder, open helper.ts file. You can see this init GPU methods here. You can see some error message. You can see the line from here. You can see the GPU canvas context is depreciated. So we have to replace this by GPU presentation context. So GPU canvas context becomes GPU presentation context. And also we don't need the swap chain, so the swap chain format here we just change to the format. Here it becomes format, and the return also becomes format. Now you can see here have some error. Property config swap chain does not exist on tab GPU presentation context. So right now they just remove this swap chain. You can see this configure, the method here returns undefined. So we don't need the swap chain here because it is undefined. Because the swap chain merged to the canvas context, so here we need to change the context. Now we can save this file and close it. Next, we need to make some changes to the wireframe.ts file. From the src folder, open the wireframe.ts file. You can see some error here. GPU swap chain format becomes format, or they change it to format. And here, the GPU swap chain right now becomes context. Same thing here. We also need to replace the swap chain with the context. Okay, we just finished the code update to the new version of the WebGPU API. So we can save this file and close it. In this example, we will reuse the common TypeScript file wireframe.ts to create the cylinder wireframe. Now open the mathfunc.ts file. From src folder, open mathfunc.ts file. This file contains the math functions used to create different wireframes. Now we need to add a new method called cylinder position to this file. This method called cylinder position. You can see here the input argument contains the center parameter here. This parameter lets you specify the location of the cylinder. This method simply returns the x, y, and z position specified by the cylindrical coordinates. We can now save this file and close it. Next, open the vertex.data.ts file here, vertex.data.ts file. First, we need to introduce the cylinder position from mathfunc.ts file. Then we add a new method called cylinder wireframe data here. Wireframe data. You can see the cylinder wireframe data. You can see here we first get the position by calling the cylinder position methods. You can see from this slice I here, the slice I contains 4 vertices. The 2 is inside and the 2 outside. From here you can see for outside 2 vertices we use R out. For inside vertex, we use RIN. We then draw 8 solid line segments for each unit cell. You can see the 8 solid line. The top surface we have 3 lines here, and the bottom we have 3 lines, and the side we have 2 lines. The flat method here is used to create a new float 32 array using all the sub-array concatenated into it. So now we can save this file and close it. Next, we need to make some changes to index HTML file from this DSRT folder. Open this file. First, we need to change the 13 to 14 because this is the 14th video. Here we need to change the H1 title from sphere wireframe to cylinder wireframe. Next, the set parameter. This is for sphere. We need to change this part, the parameter for the cylinder. You can see here we have a center and then R in, R out, and height, and the slice number n. So this is for cylinder wireframe. Now we can save this file. Next, we need to make some changes to the main.ts file. From SRC folder, open the main.ts file. This file right now is for sphere wireframe. Right now we need to replace this content with the code for the cylinder. Okay, here we first introduce the cylinder wireframe data from the vertex data.ts file. Next, here we use the input parameter for the cylinder, R in, R out, height, and number of slices, and also here wireframe data we call the cylinder wireframe data, and then create wireframe. Use this cylinder wireframe data. This is the default input parameter, and we call this function to create the cylinder wireframe. This part of the code allows the user to change the input parameter, then recreate the cylinder wireframe. Now we finished the modification to the main.ts file. Now we can save this file. Up to now we have finished all the programming. Now we can run the following command on terminal window to bound our TypeScript code in production mode. npm run prod. Okay, the bound file is created successfully. Now we can click the Go Live link from the status bar area to open the Chrome Canary. You can see the animate cylinder wireframe on this page. We can make some changes to the input parameter. For example, we change R in to 0 and redraw it. In this case, we create the solid cylinder. You see the inner radius is 0, so we get a solid cylinder. You can change the other parameters. Of course, you can also click this camera control button and use your mouse interact with the cylinder. You can move around and change the size. When you click animation again, they will animate automatically. Now we have completed this example. I have created a GitHub repository to host the source code used in this video. I will post the link for the source code below this video. You can click the link to download the source code. I will end this video here. In next video, I will show you how to create a com wireframe. See you next time. Bye.